In this first question, the graph shows the velocity versus time graph. And when you get a question with a graph, the first thing you should be doing is taking a look at what's on the axis. In this case, we have velocity versus time. And so one of the things that should jump into your head is, hey, the area under a velocity versus time graph is displacement. And the reason that I immediately went to area in order to solve this problem is because they're asking when the object again passes through its initial position. So I'm going to carefully read this question and recognize they're asking me about where it is, which is a position question. So as soon as you're asked about position from a velocity versus time graph, you should be thinking about area under the curve. Now, remember that both velocity and displacement are vector quantities. And so therefore the area that I've shaded in red here, which can be found by using 1/2 the base times the height for the area of the triangle, or in this case, the base is 1 unit and the height is -1 unit. And so we basically get -1/2 of a meter, since I have meters per second as height units and seconds. So a meter per second times a second is a meter, and that's consistent with what the units for position and displacement should be. So now I'm 1/2 of a meter to the left if we're using conventional horizontal motion, 1/2 a meter to the left of the origin. So we can see now that in the next second, if I take a look at the blue shaded region and I find the area under that triangle, again using the same geometric formula, where area is equal to 1/2 the base times the height, I'm going to find something a little bit different. I'm going to use, again, 1/2, but the base in this case is going to still be 1 second, but the height is going to be a positive value, and it's going to be 2. So we can see then that 1/2 of 1 times 2 is 1 meter. So this is positive 1 meter that I go over this interval of 1 to 2 seconds. So if I started at 1/2 of a meter, sometime over the interval 1 to 2 seconds, I'm back where I started from. Ultimately, at the end, at 2 seconds, I'll end up 1/2 of a meter to the right of where I started from. Now, if I started from the origin, then I'd be at position 1/2 of a meter, but we don't know where we started from in absolute terms. We just know that wherever we started at time 0, wherever that is, we're now to the right of it sometime between 1 and 2, and that's where choice C makes the most sense in this question.